Hello, everyone. Thank you for coming to the Rakuten Group session. I'm very happy to be able to talk to you today. We'd like to talk about the benefit of using document databases in a hybrid cloud, and we are presenting from Tokyo, Japan today. I would like to briefly introduce myself. I have been working as a database engineer since joining the Rakuten Group in 2010. When I first joined the company, I worked as a relational database engineer. Since NoSQL databases became popular, I have mainly managed them. Edward, who speaks today's main technical part, joined the Rakuten Group in 2019. Since then, he has mainly managed NoSQL database together. He has been leading the verification of the NoSQL databases and hybrid cloud, which we will talk about this time. The agenda of this session is as shown. I will talk about the first introduction and background part. Edward will talk about the technical part of the later half. First, let me briefly explain Rakuten Group and Rakuten Travel. Founded in 1997, the Rakuten Group is now one of Japan's largest web service companies. On the other hand, we are also expanding our businesses overseas in 30 countries. Overseas, we are developing Viber, a free call message app, Kobo, and ebook services, and so on. We have over 70 services worldwide and are supported by 1.6 billion users. We are actively investing not only in business but also in sports and entertainment. Recently, some people may say that they only know our company name from the NBA's Golden State Warriors uniform. This is a recently released global gross transaction value. It has continued to grow steadily since the IPO and reaching 33.8 trillion Japanese yen last year. This is also the recently released part of our Japan domestic key performance indicators. In Japan, businesses such as mobile phone, credit cards, securities, and banks continue to grow. What we will talk about today is this Rakuten Travel system. Rakuten Travel business in Japan is already outperforming the pre-COVID-19 era. Rakuten Travel is an online travel agency operated by the Rakuten Group, and the Rakuten Travel is also known as the top online travel agency in Japan. This is the rough image of the data access of Rakuten Travel. Since Rakuten Travel is a service that continues to grow, flexible system development and expansion are required. Depending on the speed of data acquisition and the shape of the stored data, we sometimes use a relational database or NoSQL database that synchronize part of the data from master data. One of our duties as database engineers is to consider the characteristics of each system and prepare the most suitable database in the most suitable form. And from the perspective of cost reduction and efficiency, basically everything is completed within Rakuten's private cloud. The NoSQL database we will talk about in the main this time is MongoDB. As you know, MongoDB is the most used NoSQL database and a kind of the document store. Rakuten Travel operates 126 nodes for sharded clusters and 24 replica sets for the document store alone. Due to the flexible feature of the system, this number may increase or decrease each month. Document Store is basically easy to use, so the number of systems using it is increasing. As an aside, the Rakuten Group is currently actively hiring engineers. So if you are interested in such an environment, please feel free to contact me on LinkedIn anytime. Before we get the point, let me give you a little background. Rakuten Travel works on various events throughout the year. When an event starts, the load on the system can swell dozens of times. Basically, we anticipate the load of the event we plan and prepare the environment in advance to withstand the load. It's not difficult for us, but some events have had difficulty predicting start times and load sizes, especially under the COVID-19. There was many such government-led events. Against this background, we consider the necessity of a hybrid cloud. Edward speaks from here.
All right, it's almost 3 a.m. here from Tokyo, but good morning, everyone. Thank you for coming today, and I hope you're enjoying Subsurface Live 2023. This is Edward Chow, a database engineer at Rakuten Travel. Just now, Tatematsu has covered some recent background information on Japan's tourism industry. Next, I will talk about why we are considering a transition to a hybrid cloud architecture for the NoSQL database clusters we're managing. First, let's consider a multi-region cluster in a private cloud environment, the architecture we are currently adopting. It offers high availability via an automatic failover mechanism. In case of a failure, the system could offload production workloads to nodes located in other unaffected data centers without human intervention, avoiding data loss or service downtime. In addition, as the cluster nodes are spread across multiple regions, applications could choose the node closest to them geographically, which would result in better performance. And this advantage is especially important for businesses providing services globally, such as Rakuten Travel. However, there are also some challenges associated with the use of private cloud. In the past few years, the Japanese government has been encouraging people to travel since the COVID-19 situation has stabilized by holding various sales campaigns such as the Go to Travel program and the National Travel Assistance program. As most of these coupons were distributed within a very limited time frame, it could cause severe congestion. Under this high load, databases involved could become unstable or even crash, causing services to become unavailable. To mitigate this risk, the most obvious solution is to accommodate peak load by provisioning additional hardware in the private cloud. However, not only is this approach inefficient and uneconomical, as additional hardware would be in idling status when the campaigns are over, but scaling this way is also not very flexible. Say we're using bare metal servers in the private cloud, preparation could take a lot of time and effort. This is where a hybrid cloud comes into play. A hybrid cloud refers to an environment that combines public clouds such as AWS, GCP, or Azure, and private clouds, where data or applications sharing between them is possible. In this context, the introduction of a hybrid cloud is done by adding nodes set up on the public cloud side to our existing cluster located in our self-managed Rakuten Cloud, as shown here on the left. Begging the question, what advantages does a hybrid cloud offer? The four major benefits brought by hybrid cloud are flexibility and scalability, cost saving, maximum resiliency, and automated management. Let me go through them briefly. While preparing on-premises machines could be time-consuming, provisioning new servers on a public cloud only takes a few clicks within seconds, while the flavor and OS middleware design could be specified using an intuitive GUI, and cluster expansion becomes seamless and swift. It could also help cut costs. It does not commit you to paying full costs for all the machines necessary when starting up new services, meaning that initial investment is more affordable. We could easily adjust the number of servers, only employing more when there is anticipated user growth during sales campaigns, avoiding waste of resources. There are scenarios where long-term usage is feasible too. While a private cloud could withstand data center level disasters, a hybrid cloud provides an extra layer of protection. Having at least one node on the public cloud active makes sure that your mission critical applications are always up, thus achieving maximum resiliency. Finally, hybrid clouds nowadays provide a wide range of features like self-monitoring and alerting, budget control, and reports generation. And these automation features make server administration a walk in the park. This is a brief introduction to a hybrid cloud. And next, I will talk about how we have verified database clusters living in it. This time we used MongoDB, a very popular or the most popular NoSQL product in the market. Many of you might have some experience working with it, but let's have a review of the architecture of a MongoDB sharded cluster. First are the MongoDB servers on the right, where data is stored. For load balancing purposes, data is distributed across multiple shards. To ensure high availability and redundancy, each shard is deployed as a replica set, which contains a cluster of servers holding the same data. By increasing the number of nodes inside, the cluster could handle more incoming requests, thus improving performance. In this verification, we added MongoDB nodes to GCP Tokyo as part of the replica sets, and various performance tests were conducted. MongoS on the left provides an interface between client applications and the sharded cluster, and acts as a query router that routes queries to appropriate shards. Those sharding configurations are stored on the config servers, which are not shown here for simplicity. Next is the verification methodology. First, we verified the speed of initial synchronization happening in a hybrid cloud cluster. Nodes newly added to an existing cluster are not immediately queryable until initial synchronization has been finished. We added a node from either the Rakuten data center side or the GCP side to an existing hybrid cloud cluster, and the times taken by initial synchronization were measured and compared. Second, we measured the read performance of a hybrid cloud cluster. Specifically, we specified read preference tags, a config that tells the MongoDB driver which node to read from, and measured the response time of read queries sent to different nodes. Results from a private cloud and a hybrid cloud were obtained and compared based on the average values. The parameters used are shown here as a reference, aiming to simulate an actual sales campaign going on. As we were using actual production data, we did not test write performance this time. However, we should be able to predict it based on the results we obtained from initial synchronization. Let's see how the hybrid cloud cluster performs. In terms of initial sync, the hybrid cloud synchronizes at 2.1 gigabyte per minute, which is 0.4 gigabyte per minute or 15% slower than the private cloud cluster. This matches our expectation, as copying files between a private cloud and a public cloud is always going to be slower than in LAN. Next is read query response time. When compared to the public cloud or the private cloud, the hybrid cloud cluster takes up to 50% more time in the worst case. But when looking at the average values, they only differ by a slight 2%. In the same vein as the initial sync, we would expect that the hybrid cloud cluster's read query response time to be much longer, especially when MongoS, the routers, need to direct the query to multiple shards across the public cloud and the private cloud. However, it is quite surprising to see that the hybrid cloud cluster holds up well, even in a mixed cloud environment. Finally, is the slow query count comparison. A slow query refers to the queries taking more than 100 milliseconds. In a production environment, we would like to avoid slow queries at all costs, as they mean that the applications will be spending longer waiting for response. By checking the slow query count, we get to know how well load balancing is. From this chart, we could see that after running 4 sets of tests on each cluster, the hybrid cloud cluster got 30% fewer slow queries, which supports the argument that increasing node count helps improve cluster performance. In short, in the hybrid cloud cluster, initial sync takes significantly longer. This is unavoidable due to higher network latency, but it is only required once during node addition and should not be a major concern. While the read query performance is comparable to the private cloud cluster, the slow query count has decreased thanks to load balancing. Here is a table comparing the time required for scaling our cluster in a private cloud and a public cloud. In the case of a private cloud, we must undergo the selection, purchase, provision, and configuration of bare metal servers before they become ready, and the entire process could take up to 4 months. In contrast, for public cloud, we only need to set up a dedicated interconnect from our private cloud to GCP and configure firewall and port forwarding before proceeding to server provision. And this could be finished in as short as 2 weeks. Creating servers on a public cloud is fast, and hence a hybrid cloud offers great flexibility. After explaining our verification results, I hope you now understand the advantages a hybrid cloud offers. Even so, there are things that we need to pay attention to when using a hybrid cloud. Let's look at some of the best practices as well as precautions. Firstly, always specify which nodes to connect to in the driver config if possible. For MongoDB, we have read preference tags to prioritize certain nodes, and other database products usually have the equivalent. For applications deployed worldwide, such settings could have a significant impact on database performance. Secondly, remember to confirm security configurations necessary with relevant parties, for example, the network department. We as DBAs often focus on database management, and it is easy to overlook something related to network security. Always discuss with the best topology and security measures with your network experts before employing a hybrid cloud architecture. Thirdly, ensure that permission settings are in place on the public cloud. This is important as other departments in your company might also be using the same public cloud for their services. Make sure that only those authorized may access your database where confidential data is stored. Fourthly, it may be a little bit too risky to go all in at the beginning with no prior experience, and it might be a better idea to start small and handle only non-critical data on the public cloud. As for the precautions, the first thing to pay attention to is latency. It is critical to database performance. Before using a hybrid cloud in a production environment, it is advisable to measure latency time and identify which regions have an acceptable latency. Some products like MongoDB do not care much about latency between different nodes, but others like Elasticsearch assume a low latency environment within a single cluster. Read the documentation carefully to see if your use case is recommended. Next is the encryption of data and traffic. Don't forget that a public cloud is public and everyone could access it with the correct credentials. To protect the data inside, we must utilize encryption at rest to prevent unauthorized access. The use of SSL, TLS, and a firewall is also compulsory. Cost monitoring is another thing that often gets overlooked. Some hybrid clouds offer the feature of dynamic scaling, which allows servers to scale automatically based on the current workload. If such a feature is enabled, it is possible that the costs associated may grow beyond expectation. It is a must to check cost information regularly. The last one is compatibility. Middleware or automation tools used internally might not be compatible with the public cloud due to OS version or hardware differences, and thorough testing with the tools is desirable. To summarize, a hybrid cloud allows us to make the initial investment as affordable as possible while maximizing system availability. It also makes the cluster more flexible in terms of scaling. However, it might not be as suitable if the existing system is already complicated or confidential data is being handled. Long-term usage of a hybrid cloud might not be as economical too. Of course, hybrid cloud verification does not stop here, as many things are still unknown to us. For instance, a hybrid cloud involving regions other than Southeast Asia, other NoSQL products, or even other public clouds. Different architectures might be required in different cases accordingly. As part of our next steps, we also plan to migrate part of our clusters in service to a hybrid cloud. With all these upcoming projects, we are seeking the best talents like you to join our team. If you're interested, do make sure to reach out to us and learn more about the opportunities available here. I hope you have learned more about hybrid cloud usage after this speech.